Very good morning, friends. Today we'll continue vectors. So this is lecture number 3 on vectors. The last time we did second lecture. Now this is third lecture. We'll continue vectors. Some notes I had to give. Position vectors of points. A, B, C, etc. with respect to origin O be given as OA bar, OB bar, OC bar, and so on. Respectively. These position vectors are also A bar, B bar, C bar, and so on, respectively. That is, OA bar can be written as A bar, OB bar can be written as B bar, OC bar can be written as C bar, and so on. And last time I gave AB bar is equal to OB bar minus OA bar, which is what? B bar minus A bar. Therefore, PQ bar is what? Position vector of terminal point minus position vector of initial point. Terminal point minus initial point. Q bar minus P bar. XY bar is what? Y bar minus X bar. Next point is, if A bar is any vector, then prove that it is A bar. Then prove that A bar is what? See the proof. Proof of 1 and 2 are same as theorem on position vector of a point. If you remember, I gave if P has coordinate x, y, z, then OP bar, according to the note, OP bar is also P bar. So P bar is what? X1, Xi plus Yj plus Zk. And magnitude of OP bar is what? Same as magnitude of P bar, which is given as root x square plus y square plus z square. Now, same way, proof of 1 and 2 we have already done as same. Here A is what? A has coordinate A1, A2, A3. Now we'll prove third one. And this also we know, vector upon its magnitude is what? Unit vector. But let us prove it theoretically. So number 3. To prove that unit vector along A bar is equal to A bar upon mod A bar. Consider A bar upon mod A bar. Since we have already proved 1 and 2, according to 1 A bar is what? A1 I bar plus A2 J bar plus A3 K bar. Divided by mod A bar is what? Root A1 square plus A2 square plus A3 square. Now separate it. A1 upon root A1 square plus A2 square plus A3 square I bar plus A2 upon root A1 square plus A2 square plus A3 square J bar plus A3 upon root of A1 square plus A2 square plus A3 square K bar. What does this imply? This implies that A bar upon mod A bar is expressed in terms of A bar upon mod A bar is expressed in terms of I bar, j bar and k bar. Therefore, a bar upon mod a bar is a vector. To prove that a bar upon mod a bar is unit vector, so we have to prove magnitude of a bar upon mod a bar is what? 1. Consider this is notation for magnitude. And how do we find magnitude of any vector? It is nothing but root of I component square plus j component square plus k component square. Here, magnitude of I component of a bar upon mod a bar is this. So a1 upon root square plus a2 upon root plus a3 upon root a3 upon root square a1 square plus a2 square plus a3 square a1 square plus a2 square and this will give you root of a1 square upon a1 square plus a2 square a2 square upon plus a3 square upon a1 square plus a2 square plus a3 square upon a1 square plus a2 square which is root 1. So this implies magnitude of a bar upon mod a bar is 1. Therefore, a bar upon mod a bar is unit vector along a bar. Now, based on this theorem, there are two notes. Note number 1. unit vector along a bar that is in the direction of a bar is equal to a bar upon mod a bar. And note number 2 is unit vector parallel to a bar. Parallel to a bar means it may be in the same direction, it may be in opposite direction. So whenever it is in the same direction, it will be positive. Opposite direction will be negative. So it is what? Plus or minus. Whenever vectors are parallel and same direction, whenever vectors are parallel and are in same direction, then it is called like parallel. And whenever vectors are parallel but are in opposite direction, okay, they are known as unlike parallel. Next part is section formula in vector notation. If A bar and B bar be position vectors of points, it is not its, it is points. POINTS or PTS. PTS is short form of points. Points A and B respectively, if point C divide AB internally in the ratio m is to n, then prove that position vector of point C is given as C bar is equal to mb bar plus na bar upon m plus n. Hence, find position vector of midpoint of AB. This is O A B. Position vector of point A is what? A bar. That is OA bar is what? A bar. OB bar is what? B bar. And the point C divide position vector of C is what? C bar. AC upon CB is M upon N. Consider segment AB. Let point C divide AB internally in the ratio m:n. That is, length AC upon length CB. Length AC upon length CB. M by N. Equation number 1. Let position vectors of points A, B and C with respect to fixed point O be A bar, B bar and C bar respectively. Since length AC upon length CB length AC upon length CB M by N from equation number 1. Therefore, N into length AC M into length CB. See, length AC is one segment and CB is another segment. This is AC, this is CB. The magnitude of when N is multiplied to length AC, it is another segment whose length is what? N times length AC. And CB is what? Length of this segment. M times CB is what? Magnitude of another segment. So the magnitudes of the two segments are equal. Direction of AC and CB are same. So directions of the two new segments will also be same. This implies magnitudes of two segments are equal. Also, directions of AC bar and CB bar are same. Therefore, directions of two segments are will also be same. Therefore, writing them in equal vector form, we get n times AC bar m times CB bar. AC bar is same as C bar minus A bar. CB bar is B bar minus C bar. That is position vector of terminal point minus position vector of initial point. Therefore, n times C bar minus n times A bar, MB bar minus MC bar. C bar being on one side, so MC bar plus NC bar, MB bar plus NA bar. Transfer A bar on that side. C bar common, N plus N, C bar is equal to MB bar plus NA bar. So C bar is what? MB bar plus NA bar upon N plus N. Is position vector of point C. Now after this we have to find out, hence find position vector of midpoint of segment AB. To find position vector of midpoint of segment AB. Point C will be midpoint of segment AB provided n is equal to n. Midpoint of segment AB provided n is equal to n. In this case, position vector of point C will become C bar is what? MB bar plus MA bar upon, since n is equal to m. Therefore, C bar is what? M common. B bar plus A bar upon. So C bar is what? A bar plus B bar upon 2 is position vector of midpoint of segment AB. So this is your midpoint formula. Next one is section formula in vector notation for external division. In this case, midpoint will not come. Section formula in vector notation external division. If A bar and B bar be position vectors of points A and B, respectively, if point C divide AB in externally in the ratio m is to n, then prove that position vector of point C is C bar is equal to NB bar minus NA bar upon n minus n. Bus, this part is not there. See the proof. This is segment AB. A, B, and this is point C. This is origin. Position vector of A with respect to origin is what? A bar. C with respect to origin is what? C bar. And this is B. B bar. C divides segment AB in the ratio M is to N. Consider segment AB. Let point C divide segment AB externally in the ratio M is to N. That is length AC upon length BC. M by N. Let position vectors of points A, B and C with respect to fixed point O be A bar, B bar, and C bar respectively. Since length AC upon length BC m by n, so n times length AC m times length BC. So this implies AC is one segment and BC is another segment. So length AC may not be equal to length BC, but when we multiply n times length AC, it will be a new segment, and m times BC will be another new segment. Magnitudes of the two new segments are equal, and direction of AC and BC are same. A to C and B to C are same. Therefore, writing them in equal vector form. So what we'll write? Magnitudes of the two segments are equal. Also, directions of AC bar and BC bar are same. Therefore, writing them in equal vector form, we get n times AC bar is equal to n times BC bar. So n times AC bar is what? C bar minus A bar. C bar minus B bar will give you NC bar minus NA bar, MC bar minus MB bar. Bring MB bar on this side, transfer MC bar on that side. MB bar minus NA bar is equal to MC bar minus MB bar minus NA bar is what? M minus NC bar. What is C bar? MB bar minus NA bar upon M minus N. Is position vector of point C in vector notation in external division. Next is centroid formula of triangle. If A bar, B bar and C bar be position vectors of vertices A, B and C of triangle ABC respectively, prove that position vector of centroid G of triangle ABC is G bar is what? A bar plus B bar plus C bar upon 3. See the proof. This is triangle ABC. What is centroid? It is meeting point of medians of triangle. Centroid is what? Meeting point of medians of triangle. Whereas in center is what? Meeting point of angle bisectors of triangle. Orthocenter is what? Meeting point of altitudes of triangle. And circumcenter is what? Meeting point of perpendicular bisectors of sides of triangle. So this is triangle ABC. Let AD is what? Be its median. So this is median. So it will be midpoint of side BC. Centroid divides median internally in the ratio 2:1. This part is 2, this part is 1. The first two lines I will write regarding centroid. Centroid is the point where all three medians of triangle meet each other. Centroid divides median internally in the ratio 2:1. Consider triangle ABC. Let AD be its median. Let G be a point on median AD which divides median AD internally in the ratio 2:1. Therefore, G will be centroid of triangle ABC. Let position vectors of points A, B, C, D and G with respect to fixed point O be A bar, B bar, C bar, D bar and G bar respectively. Since D is midpoint of side BC, therefore by midpoint formula, D bar is what? B bar plus C bar upon 2. Since G divide median AD internally in the ratio 2:1, therefore by section formula of internal division, G divides, position vector of G bar is what? G is G bar, 2 into cross multiply, 2 into D bar, second point of the segment, plus 1 into A bar upon 2 plus 1. And D bar we got B bar plus C bar upon 2. 2 into B bar plus C bar upon 2 plus A bar upon 3. 2 to cancel. So B bar plus C bar plus A bar. So G bar is what? Is position vector of centroid G of triangle ABC. There are two corollaries based on this centroid. Corollary means sub-theorem. To prove corollary, we have to use theorem as a formula. If G is centroid of triangle ABC, prove that GA bar plus GB bar plus GC bar is what? 0 bar. Since G is centroid of triangle ABC, therefore by centroid formula, G bar is what? A bar plus B bar plus C bar upon 3. So 3G bar is what? A bar plus B bar plus C bar. Write this as equation number 1. Now whatever we to prove, that will take. Consider GA bar plus GB bar plus GC bar. GA bar is nothing but position vector of terminal minus position vector of initial. A bar minus D bar. Same way B bar minus D bar plus C bar minus D bar. A bar plus B bar plus C bar you take together. Minus D bar minus D bar minus D bar will give minus 3G bar. And this is what 3G bar. Therefore, GA bar plus GC bar will be what? 0 bar. The next corollary is, if G1 and G2 be centroids of triangle A1, B1, C1 and triangle A2, B2, C2 respectively, then prove that A1, A2 bar plus B1, B2 bar plus C1, C2 bar is equal to 3 G1, G2 bar. This is G1, G2 bar. G1, G2 bar. Since G1 and G2 be centroids of triangle A1, B1, C1 and triangle A2, B2, C2 respectively. Therefore, by centroid formula of triangle, G1 bar will be what? A1 bar plus B1 bar, and G2 bar is what? A2 bar plus B2 bar plus upon 3, where A1 bar, B1 bar, C1 bar, A2 bar, B2 bar, C2 bar, G1 bar and G2 bar are centroids of position vectors of points A1, B1, C1, A2, B2, C2 and G1 and G2 respectively with respect to fixed point O. So 3G1 bar is what? Is equal to A1 bar plus B1 bar, and 3G2 bar is what? A2 bar plus B2 bar plus C2 bar. Consider A1, A2 bar plus B1, B2 bar plus C1, C2 bar. A1, A2 bar is what? A2 bar minus A1 bar plus B2 bar minus B1 bar plus C2 bar minus C1 bar. Now we'll take positives together, A2 bar plus B2 bar plus C2 bar. माइनस A1 बार प्लस B1 बार प्लस C1 बार. Now A2 bar plus B2 bar plus C2 bar is what? 3G2 bar minus 3G1 bar. 3 common, G2 bar minus G1 bar, which is same as 3 times G1 G2 bar. Therefore, A1 A2 bar plus B1 B2 bar plus C1 C2 bar is equal to 3 times G1 G2 bar as required. One note I'll give you. Centroid G of tetrahedron ABCD is G bar is what? A bar plus B bar plus C bar plus D bar upon 4. Thank you very much. In the next video, we'll continue problems based on whatever theorems we had done. So today's quote is what? Honesty is the best policy. ईमानदारी एक अच्छी नीति है. इसी नीति पे हमको चलना है. जो आया है खाली हाथ जाने वाला है. इसी बीच में यानी जन्म से लेकर मृत्यु के बीच में हम लोग सिर्फ लोगों के गले काटने और बेईमानी करने का धंधा करते रहते हैं और जितना पाते हैं हम कोशिश करते हैं जमा करने की और ऊपर वाले की नज़र में डेफिनेटली ये एक बड़ा पाप है. ये हम सब जानते हैं लेकिन फिर भी करते रहते हैं. एक दिन कब आएगा जब आप आंख मूंद लोगे और ऊपर चले जाओगे. सारा पैसा रुपया जो बेईमानी से कमाया है सब यहीं छूट जाएगा. इसलिए ईमानदारी को हमेशा अपनाओ. ये अच्छी नीति है. थैंक यू वेरी मच. सी यू इन द नेक्स्ट वीडियो.